In this video, we're starting section 1.6 on inequalities. Our goals for this section are first, we'll solve linear inequalities, then we'll do some example solving quadratic inequalities. These two are probably stuff that you would have seen before, so it's going to be a bit of a review. And then we'll talk about how we solve non-linear and non-quadratic inequalities using what's called the cut point method. So that you may be less familiar with, that this might be a new concept. Okay, so let's get into linear inequalities. So a linear inequality has the form, it's kind of like the equation of a line where you have, an mx plus b on one side, like some coefficient m in front of like an x variable. Maybe there's another constant next to it, b. And then there's some inequality. It doesn't have to be greater than or equal to. It could be any other inequality as well. And then perhaps some other number on the other side, which I'm just calling c. Okay, so let's look at an example. Suppose I have the inequality negative 3x minus 2 is less than 10. And I want to solve for x. Well, you might recall from algebra class that the strategy is to isolate for x. We want to try to get the x by itself. So first I got to move this negative 2 over to the other side. So I'll get negative 3x. I'll add 2 and get less than 12 then. And then I divide by that negative 3 and I'll be left with x. On the other side, I'll get negative 4. And remember that when you divide both sides of an inequality by a negative, or if you multiply both sides by a negative, you got to flip the inequality. So this will become a greater than. Okay. All right, so now let's plot this on a number line. And then I'll do interval notation. So tick mark at negative 4. It's not allowed to be equal to, so open circle. And then I shade in the things that are bigger than negative 4. That's the stuff to the right. X is greater than negative 4. So in interval notation, it's a parentheses at negative 4, comma, and then onwards to infinity. And remember, infinity always has a parentheses. Okay. All right, so this is actually 3 ways of writing my answer, either in interval notation or on a number line, or just as an inequality, I've isolated the x. Okay, typically in most inequality problems, I'll ultimately ask you to put in interval notation. Okay, so I want to talk about graphically what's going on here, because the graphical idea is going to help us when we get more complicated inequalities. So the idea is that if I have an inequality like this, I can rearrange it to make one of the sides 0. So if I take the 10 and I subtract it over to the left, it'll become this minus 12. Okay, so what I'm going to do now is I'm going to consider the graph of y equals negative 3x minus 12. So I'm going to draw some axes. Okay, so I know the y-intercept is negative 12. And it's got this slope of negative 3. So that means the line is going to be going like this. It has this negative slope. And if we were to solve for this x-intercept by setting this whole thing equal to 0, we'd end up getting that value is negative 4. Okay. So graphically, what am I looking for here? I'm trying to figure out when this function, negative 3x minus 12, when is it less than 0? So I want to know when the y values of this function are less than 0. So where does that happen? I'm going to start to shade those in. Where are the y values less than 0? So the y values are less than 0 on this whole part of the graph. I got negative y values here. These are still negative. These are still negative. But when I get to that x-intercept, I'll put an open circle, because that's where the y value equals 0, but there's no equal sign on this inequality. And I definitely don't want to do any of these values, because those are positive y values. Okay, so this orange region is where the solution to the inequality should be. Okay, so I need to figure out, I need to just answer now, well, what are the x values for this part of the graph? Well, those x values start at negative 4, parentheses, it's not including negative 4, and then they get bigger and bigger and bigger onwards to infinity. And that's my answer. That's my solution. Okay, so graphically, that's how we can think about the solution to this inequality. As we'll see, in the next video and onwards, this idea of getting 0 on one side of the inequality is going to be very useful in solving them. Because then we just got to think about when does our function either have negative x values or, sorry, negative y values or positive y values.